या व्हिडिओमध्ये मी आपल्याला ग्रुप थेअरीचे MCQ क्वेश्चन्स देत आहे. MCQ of group theory. First, a group G star is an abelian group if star is dash 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 over G if for all AB belong to G. G star is abelian and therefore star is commutative. Commutative. Answer is A option, commutative. Second, a group G plus is abelian if for all AB belong to G, then dash dash dash. Here operation is addition and group is abelian, means A plus B equal to B plus A. Answer is option B, A plus B equal to B plus A. Third one, if G is a group and ABC belong to G such that AB equal to AC, then AB equal to AC, then now A cancel. By using left cancellation law we get B equal to C. Answer is B option, B equal to C by left cancellation law. Next one, fourth, let G be group with respect to multiplication such that A inverse BA equal to. Now consider A inverse BA equal to A inverse into B inverse into B into A. By associative law, equal to we get A inverse into EA because B inverse into B is identity. So equal to we get A inverse into A. A inverse into A is identity, means A inverse BA equal to identity. So answer is B option, E. 5. A group having 4 elements dash dash be always abelian. Must be abelian. A group having 4 elements must be abelian. The inverse of 7 in the group G multiplication 8, where G is modulo 8 means 1, 2, 3, 4, 5, 6, 7. Then inverse of 7 is again 7. Option D, 7. If phi n is Euler's function, then phi 8 is equal to dash dash dash. Euler's function phi from n to n defined by phi n equal to number of positive integer less than or equal to n and relatively prime to n. Now 1, 3, 5, 7 are positive integer less than 8 and relatively prime to 8. 8, 1 and 8, their GCD is 1. 3 and 8, GCD is 1. 5 and 8, GCD is 1. 7 and 8, GCD is 1. Mean these numbers are relatively prime to 8. So 1, 2, 3, 4 numbers. Answer is C option, 4. If P is prime and phi n is Euler's function, then phi P is B option, P minus 1. 9. If the order of an element A in the group G is 1, then let G be group A belong to G. Then the definition of order is the smallest positive integer n if it exists such that A raised to n equal to E is called order of A and is denoted by order of A. This number n, if A raised to n is identity, then number n is called order of element A. Now here given order of A is 1, order of element A is 1, means A raised to 1 is E. A raised to 1 means A equal to E. So answer is D option, A equal to E. 10. The order of 3 in the group Z12 addition is. Operation is addition. So in addition, identity element is 0. The smallest positive integer n if exists such that A raised to n equal to E is called order of A, it is denoted by order of A. Additive identity is 0. Here operation is addition. Additive identity is 0. E equal to 0. Z12 equal to 0 to 11. Now 3 raised to 1. Order of 3. 3 raised to 1 is 3 is not equal to 0. 3 raised to 2 is 3 plus 3 is 6 is not equal to 0. 3 square is 3 plus 3 is 6 is not equal to 0. 3 cube is 3 plus 3 plus 3 equal to 9 is not equal to 0. 3 raised to 4, 3 plus 3 plus 3 plus 3 is 12. 12 is 0, means order of 3 equal to 4. So answer is B option, 4. 11. If G equal to 1 minus 1 I minus I is a group with respect to multiplication, then order of I equal to dash dash dash. Again write down definition of order of element. A raised to n is E, then number n is called order of element A. Now here operation is multiplication. So multiplicative identity is 1 means E equal to 1. Now I raised to 1 is I is not equal to 1. I square is minus 1 is not equal to identity element 1. I cube is minus I is not equal to identity element 1. I raised to 4 is 1. This is identity element. So n means 4. Order of I equal to 4. Answer is D option 4. 12. If G equal to 1 minus 1 I minus I is a group with respect to multiplication, then order of minus 1 is dash dash dash. Again write down same definition. A raised to n equal to identity, then n is called order of element A. Now here operation is multiplication, so multiplicative identity is 1 means E equal to 1. Now minus 1 raised to 1 is minus 1 is not equal to identity 1. Minus 1 square is plus 1 is equal to identity 1 means order of minus 1 is 2. Order of minus 1 is 2. Answer is B option 2. 13. If G equal to 1 minus 1 be group under multiplication, then order of minus 1. Same type of problem. Write down same definition. A raised to n is identity, then n is order of element. Here again operation is multiplication, so multiplicative identity is 1. Now order of minus 1, so minus 1 raised to 1 minus 1. Minus 1 square is plus 1. Identity element, so order of minus 1 is 2. So answer is B option 2. If Z11 multiplication is a group, Z11 multiplication is a group, then order of 3 is equal to. Z11 is 0, 1, 2, 3 up to 10. Now 3 raised to 1, order of 3, so find out 3 raised to 1, 3 is not equal to identity because multiplicative identity is 1. 3 square 9 is not equal to multiplicative identity 1. 3 cube 27. 27 is congruent to 5 modulo 11. 3 raised to 4 is 81 is congruent to 4 modulo 11. 3 raised to 5 is 243 is congruent to 1 modulo 11, and this is identity, multiplicative identity means order of 3 equal to 5. Order of 3 is 5, so answer is C option 5. 15. If A is any element of finite group G, then A raised to order of G is A option identity element. 16. If G is abelian group and AB belong to G, then A into B raised to n equal to A raised to n into B raised to n. A option. If G is a group and AB belong to G, then A into B inverse equal to B inverse A inverse. Answer is B option, B inverse A inverse. 18. If G is a group, then for A belong to G, then A inverse its inverse equal to A option A. Any two right coset of H in a group G are disjoint or identical. Answer is C option, disjoint or identical. If 20, if H is a subgroup of group G and A belong to H, then AH equal to H. C option, AH equal to H. 21. The group Z plus is cyclic group generated by 1. B option 1. For a fixed natural number n, the set nz plus nz addition is cyclic group generated by this number n. Answer is B option n. 23. Union of two subgroup of a group is need not be subgroup. Union of two subgroup need not be subgroup. 24. If H and K be subgroup of a group G, then H union K is also subgroup of G if and only if either H is subset of K or K is subset of H. B option. Answer is B option, either H is subset of K or K is subset of H. If A and B are two subgroup of group G, then dash dash is certainly subgroup of G. A intersection B. C option, A intersection B. Every proper subgroup of group of order 77 is A option, cyclic. 27. If G is a finite group of order 15, then order of proper subgroup of GR. 15 is product of 3 into 5. So 3 and 5. Subgroup of order. Answer is C option 3, 5. Every subgroup of cyclic group is B option, cyclic. Every subgroup of cyclic group is cyclic. 29. If H is subgroup of a finite group G, then answer is B option, order of H divide order of G. This is Lagrange's theorem. 30. Any two left coset of H in a group G are identical or disjoint. Answer is B option, identical or disjoint. 31. Homomorphic image of a cyclic group is. Answer is B option, cyclic. 32. Every finite cyclic group is isomorphic to. Answer A, Z plus. 33. A 1, 1 and 2 homomorphism is called isomorphism. A option, isomorphism. An isomorphism from a group unto itself is called C option, automorphism. Isomorphism from G to G is called automorphism. Let Z be additive group of integer f of Z to Z defined by f of n equal to 3n. Then f of m plus n is 3m plus 3n. Answer is B option, 3m plus 3n. 36. If Z is set of integer under addition and f of Z to Z defined by f of n equal to n square, then f is first check that this is homomorphism or not homomorphism. F of n is n square, so f of n plus m is n plus m bracket square. Now expansion of this is n square plus 2nm plus m square. Now find the value of f of n plus f of m. F of n is n square and f of m is m square. Now both are not equal, means f of n plus m is not equal to f of n plus f of m. So function f is not homomorphism. So answer is C option, not homomorphism. 37. Let Z be additive group of integer and f of Z to Z defined by f of n equal to 2n. Then kernel of f is equal to dash dash dash. We know kernel of f definition is x belong to Z such that f of x equal to 0. So x belong to Z. Now f of x by definition is 2x equal to 0. Therefore x belong to Z such that x equal to 0, means kernel f is only 0 element, singleton 0 element. So answer is C option, 0. 38. If f of G to G dash be a group homomorphism, then f is dash dash if and only if kernel f equal to identity. If kernel f is identity, then the homomorphism is which type of? Means 1, 1 or onto. So first check that 1, 1. So for that f of a equal to f of b. Assume that f of a equal to f of b. Now f of a into f of b, its inverse equal to e dash. So f of a into f of b inverse equal to a dash, means f of ab inverse equal to a dash. E dash means ab inverse belong to kernel f, because f of ab inverse is e dash, so ab inverse belong to kernel f, and we know kernel f is identity element, so ab inverse equal to identity means a equal to b. So we get f of a equal to f of b, which imply that a equal to b means function f is 1, 1. Answer is C option, 1, 1. 39. If Zp is finite field, then p is prime number. C option. 40. If p is prime, then Zp is. If p is a prime, then Zp is. In the previous example, if p is prime, then Zp is field. Now every field is integral domain, so p is a prime, so Zp is integral domain. So answer is C option, integral domain. 41. Every field is integral domain. Answer is A option, integral domain. 42. If z plus into is integral domain, then z is not filled. Z is not filled. If R plus dot is filled, then R is ring without zero divisor. This is a field, then R is ring without zero divisor. If R is a ring and AB belong to R such that A plus B square equal to A square plus 2AB plus B square, then R is dash dash dash. Now given A plus B bracket square equal to A square plus 2AB plus B square. A plus B square means A plus B into A plus B equal to right hand side as it is. Open this bracket, A into A plus A into B plus B into A plus B into B equal to A square is A into A, 2AB is AB plus AB, B square is B into B. Then A and A cancel, BB cancel, also AB cancel, remains only BA equal to AB. BA equal to AB means R is commutative, and therefore answer is option C, commutative.